is helpful notes, and everything in blue you answer. I'll pause and let you answer the blue, and then you get the answers. And this one here, pre-image, remember that's the original thing, the image is a new one. Translation is going to be plus to the right, and then left will be net minus, y is going up, plus, going down, minus. This preserve congruence. This is always reflections, x stays here, y stays here for every original thing. Reflection, I'm going to say it's fixed. Remember that part? Fixed life. So the x will stay fixed, x will stay first. And it's reflected over the y-axis, the fixed life, the y would stay fixed, and then the opposite the axis. Okay, and it does preserve congruence. Rotation, the rules, and this remember this is going to the right clockwise. So going counterclockwise would be the opposite. We still have x, y, y, x, x, y, y, x, x, y, y, x, x, y, y, x, x. Okay. The original thing is going to be right here, definitely right here. That's 0. When you go to the left, you have to go here negative. And both, and then here, and there it is. Dilation is the only one that is not congruent. And let's just go to the slide. Let's do the next page. Okay, this is going to be for you on a figure on the coordinate plane is transformed. Okay, determine whether its transformation preserves congruence or does not. Rotation, reflection, translation, all preserve congruence. Dilation is the only one that does not. Square A, B, C. Translate, that means to slide 3 down. And we what? X, what? X, what you mean with that one? And then that's it. It just goes straight down. Okay, so we go x minus 3, and then y stay the same because it doesn't say anything about going up or down. Triangle Joe is reflected, fixed life over the x-axis, so the x stays exactly the same. Which rule represents transformation? So it's going over the x stays the same. The correct transformation rule. There it is. Okay, right here, let's see this one right here. This is a dilation. You can see it's getting, since the S here has no prime, this one has a prime, it's getting smaller. So we know it's going to be a reduction. Okay, it's going to be a reduction. And I'll always go, in my opinion, I always go just basically not thinking at all. Let's go back there. It's going to be new over the old. And the new one here is what, 1 over 3, 1/3. Which rule is the thing? So it's going to be 1/3 x and 1/3 y. Just giving you a heads up, that's how you do that one. Okay, triangle ABC is rotated, 180 degrees counterclockwise. This is pretty easy actually. I guess I'll just move up, making right zeros here. For 0, then 90, 180, 270, 360. It always goes with x, y, and then y, x, x, y, y, x, x, y. And then we're going to go counterclockwise, so it goes to the left. And that means the first rule, the first one stay the same. The last one stays the same. Now we go to the left, to both, and here. We should know this one always, it's always going to be negative x, negative y. I should change that to blue. Negative x, negative y. It's not asking for this, but please remember that rotation keeps it congruent. Keeps it congruent. So these here are notes for y'all, unit rate and slope. Remember, this is also going to be, we always want it to be known for us here, M. And once you see this stuff here, it should automatically be thinking of what list and spreadsheets, menu 413, always in the form of y equals to mx plus b. Always get 2 points. This one is proportional going to the origin. That's a good coordinate. That's another good coordinate. 0, 0, and 430. And then anytime you read the question, going through here like this, keywords, anything that says per, each, every, those are your M's. So M is your slope, don't forget that. You can think of those and think of each, every, per, any kind of that idea. Per, every, each, and our keywords for slope. Anything with ly, anything daily, weekly, hourly, that's going to be a slope again. Okay, let's see. Questions. So coming over here, which proportional, I told you a proportional means to what? Goes to the origin. This is a proportional graph going to the origin. This is proportional. This one's not proportional, it goes to the origin, but then it does like a curve or whatever. No, it's not proportional because it does not keep a straight line. This isn't proportional. Proportional, so x and y. So because it has that plus something out, minus something out. That one, no, it has to be x something with an x plus a b of a 0, which would be like plus 0 slash, we don't write that. So this is the only one. And that's actually that exact same line going to the origin. Proportional relationship. Right now, we're going to say where it goes to the origin. Remember, if it goes to the origin, that means that b is equal to 0. So for all these right here, once you see this, you want to think of list and spreadsheets. And 4, 1, 3. And we'll do it like that. And it's just, well, I'm going to do it once. And then all of these, I'm going to type in the numbers over it. And it should basically just go ahead and change it up. And all I'm looking for it to be proportional, that the b is equal to 0. So let me time out. So we're going to go to list and spreadsheets and double check. We're going to put all these points in. And then double check that they go to the origin slash where b is equal to 0. So I'm going to come back here. Since I already had one set up, I'm going to come out here and put the numbers in here. I think I have a -1 here, a 1 here, and a 2 here. Okay. Okay. And then, actually, let me see the numbers again. We have 1, 1, 2, 4, 8, 10, 12, 4, 8, 10. Here's 12. I'm going to go here. 4, 8, 10. And there. So my B is not a 0 there. You know what? That's as many as I can remember, so that's not right. Let's come back and check number. Is that a 1? 1, 2, 3. And it's 0.5. And this is a weird 1, 2, and 3. 1, 2, and 3. 1, 2, 3. And I read this one being great. I think it's 5. 5.5. And it's 6. Oh no, 5.5, 6, and 5. 5.5. 6, really weird. And then 5. So no, that's not going to work at all. 5.5, 6, and 5. So let's go back and check the next one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And what I'm looking for is that the b to be 0, so it can be proportional. Please God, let's check the last one. 2, 4, 6. 2, 4, and 6. And then this top part over here, it's going to have 1.5, 3, 4.5. 1.5, 3, and I believe 4.5. And your b goes to 0, so yes, that one is proportional. So again, when you see this right here, your b is equal to 0, and your b is equal to 0, that's going to be that it is proportional. Okay, that means when you graph it, and actually we can graph this thing real quick. I'm going to come here, control document. We're going to go ahead and add a graph. It should be starting off at 2 because our first thing is from here. And you see how it adds a plus 0 already? Enter, and it's going through the origin. So that is a proportional relationship. Perfect. So the one that's proportional is, oh, please, oh, it's still recording. Okay, so J. So linear, again, we're going to go back to the idea y equals mx plus b. Remember the slope, your m, each, every, per, daily, weekly, hourly, all that ly stuff is your m. Your b is your intercept where it crosses the y-axis. I guess we'll do Mr. Slope real quick. Over here, positive if it's going up, negative if it's coming down. This is an undefined slope. This here is a zero slope. Let me see what other things we can put and throw in here. Yeah, don't remember m. Yeah, going to be each, per, anything ly like daily, weekly, hourly, every. Okay, this is a one time b. Your b is one time. One time b. It can be a discount. All right. All these little things. I'll give you an example. Y is equal to 2/3. Sorry, 2x plus 3. This is your m. And then the b would be your 3. Okay. Let me see where we're going with next. Okay, so let's go here, read the question. So on this note here, sample star test question. Actually, a real star test question back in the day. Which table contains only corresponding x values and y values where the value of y is 3 more than the quotient of x and 2? So this is not even hard. It's like baby stuff. And the idea of quotient and keywords is the one that's going to give you this, the dead giveaway of what's going on here. Y is, that's y equals. Right here. Y equals 3 more than. Yeah, 3 more than. That means we're going to go y equals. And that's from 7th grade, you put the plus 3. 3 more than plus 3 at the end of the, the equation. Quotient means to divide of what two numbers? X and 2. So you have x divided by 2 plus 3. On that note right there, this is a sneaky idea here. You decide what you want, right? But this is also saying we're going to have y is equal to 1/2 x plus 3. This is a very good question. Now, this makes sense. If you have x and you divide it by 2, well, isn't that the same thing as getting half of x? So that's the idea, right? Now you have to come out here and use these list spreadsheets, tables. Once you see tables, list spreadsheets, menu for 1, 3. And then we're going to come out here and find out which one gives me the idea right here, where we're going to have the equation of y is equal to 1/2 x, or the quotient of x and 2, and plus 3, or the 3 more than the quotient of x and 2, which I prefer to write it and see it as this. Y is equal to 1/2 x plus 3, which m would be 1/2, and then b would be 3. On this note right here, guys, please make sure you know that 1/2 is also equal to 0.5. So that's what we want to be looking for. We want to be looking for these two things here, m to be 0.5 and b to be 3. Why? Because the tables, when you do this in spreadsheets, they're going to give you a decimal in the beginning. So let's come out here, and it's saying this is the answer right here. And so I'm just going to go ahead and just put the top two numbers in, top two coordinates, 7, 5, yeah, and 7, yeah, we'll work on that. Show you the difference, okay? We're going to go 7 and 10. So I'm going to go 7, 5, 10, 6. Go back to the calculator. I'm just holding this document. I like to go ahead and have it work. I don't have anything to worry about. And 7, 5, 10, 6.5, and I'll come back over here. I'm going to go to menu, 4, 1, 3, Control E, Control outside, and enter. So if you remember the equation we want is y is equal to 1/2 x plus 3, and this is 0.15, so that's not right. So we're going to go back over here and double check. We're going to go with the 7, 6.5 and 8. 6.5 and 8. 6.5. Okay, if you don't mind getting that, and 8. And now there's my 3, which is perfect, which I want to go now. So that's how I want to do this. Double check. That's more of a reading question. I think y'all know how to do the menu for 1, 3 already, which you need to go ahead and read. Same idea here. Well, once I see this graph, guys, and once I see this right here, man, automatically 2 points. Listen spreadsheets, menu for 1, 3. Just do it to it. This is my y-intercept right there. You think about that? What does that tell you? It cannot be this one. It cannot be this one. And then now we get another point here. I think that was like the best one right there. So this coordinate here is 0, 32. And then this number first, 40 and 104. Okay, so 0, 32 and 40, 104. So luckily I just did one. I can just go 0, 32, and 40, I believe 102. I forgot. Let me just see. It's 104 actually. 104. Okay. So we have this thing called, what, 1.8? Well, I know it's bigger than 1, right? Let's look at the answer choices. So again, going over here, I know it's 1 point something, so bigger than 1. This is less than 1, so that one's out. So it has to be this one right here. And just to double check, you're going to go to make that fraction, right? So I believe it's a 1.8, and when I get to a fraction of 9/5, go back to the calculator. We're going to go to Control C, and Control Doc. We're going to add a calculator. We're going to Control V, and then we're going to go to Menu 22. And there it is, 9/5. So I do feel way more confident that that is my answer with a 9/5 next slope. And that's it. It was super easy, this test, or these ideas on the test. Again, this is spreadsheets menu for 1, 3. This is like super easy. Kind of the sense that, look at this, 0, 15. You already know that's your y-intercept. So it can't be that one, can't be that one. And as x's get bigger, your y's get smaller. So it's going to be, well, maybe I kind of messed up here. You can't, this is like a really big jump in x's, and this is barely going down. So it's barely going down that super small moves, and this is super big moves, so no way. But this is double check. So again, I'm going to do this in spreadsheets. I'll start a whole new one, and we go 0, 15, and 75, 12. 0, 15, and 75, 12. A whole new one. Again, 0, 15, and if I remember correctly, 75 and 12. So I go here, menu, 4, 1, 3, and this has to be B. Control this side, enter, and okay, so I definitely do feel that that one's going to be, what, 15, which is great. And so that definitely makes me go ahead and say, yes, that one's out, out. Now, what happened in this situation? It definitely did not give me the answer. So that one's out, and it has to be this one. But what I'm going to go here and do is I'll go to Control C, copy and paste, and do all that. So you can go ahead and see that this is that point, negative 0.04, I think. And negative 0.04. I'll go right here, practice that again, Control C, Control Doc, and we're going to add a calculator. We're going to go to Control V to paste it, and we're going to go to Menu, and we're going to go to 2, and if you look at this, it's 2 a fraction, so we're going to say yes, enter, and there it is. So there's my equation, and you know, pretty easy, it's not too bad. Okay, next question. Use the table. Okay, once I see this, guys, listen spreadsheets menu for 1, 3. Okay, that's it. Y-intercept, again, that's easy. Please, if you're really quick and sharp in your stuff right here, when your when your y-intercept, it's on the y-axis. You're on this point right here. Anywhere on this line here, that's where your line would cross, making it a y-intercept. When you're on the y-axis, x is equal to 0. So there it is right there. This is your y-intercept right there. 0, 3, or just 3, whatever you want to call it. I'll put both, just double check. But I want you all to just think about this in general. Once you see 2 points, once you see a table, this is versus menu 4 and 3. And just, I'll use -1, 5, and 0, 3. And just start it all over. Negative, come out, -1 and then 5. And then 0, 3. Come back here, go to menu, 4, 1, 3. And then this will be your B. And control left hand side, enter, enter. And there is your slope, -2, and your y-intercept of 3. -2 and 3. Let me double check that. Yeah, -2 and 3. That is just what is my y-intercept? It could ask you for the y-intercept as a coordinate, so you can put 0, 3, right? Either or, pretty good. Put double arrow like pointing this way or that way, so they're both equal to each other. The breaker delivery is yada. Delivery fee, that happens once, guys. That happens once. So that's your B. The breaker charges a total of 6. Oh, great. This is easy, guys. This is the coordinate right there. You see it? This is the coordinate right there. So, what do we do here? Let me see. Let me get it ready. Okay, so for me on this one, what I like to do here is I got to look at this, and I see 2 coordinates here. There's an x and a y here, and there's another x and a y here. And when it comes down, look at the equation here. Which equation represents, right? Which equation? So they want the idea of, again, y equals, and then x plus your b. So it's going to go in there, and we're going to use this idea here, but you have to know which is your x and which is your y. So on that note, I like to think about this one, and the whole idea is, well, how does this work? Well, everything has like one thing first and something second. So which one comes first? Do the cookies come first or the money? Well, you tell me how many cookies, and then I'll tell you how much you're going to have to pay. And that's usually like the way it is. How many pizzas you're going to order with them, how much you're going to pay. How many Cokes you're going to buy, and then that's how much you pay. So that's the idea here. So for this coordinate here, we're going to have 16 cookies. I'm going to have 16. I'm going with 16, 60. And then let's check this next one over here. We're going to go with 22 cookies for 21.70. So I'm going to do this in spreadsheets again. Those are my 2 coordinates. And there is a delivery fee over here, but it's already included. Okay. So let's go ahead and work on this. 16 and 60. So I'm going to go with 16 and 16, 60. And then 22 cookies for, I believe it's 21.70. I believe. Okay. Oh, look, yeah, there's your delivery fee at one time at 3. You can see right here. And then each one is 85 cents. So how do you get each one of 85 cents? Remember I told you the slope is how it changes, and it's going to be for every. Okay, coming back over here. So my equation for this one will be y is equal to 0.85x plus 3. So each one right here, guys, each cookie, every per is going to be what? 85 cents, or 0.85, and plus 3. So again, in case you can't read it, y is equal to 0.85x plus 3. Okay, so Miss Sam went to Target and bought pens that cost $5 per set. That's it. Per. That's your 5. It's going to be 5x. Sam bought $1 off coupon. That's your discount. So that's your equation. Y is equal to 5x minus 150. My bad. So now what I have to do is put these distance spreadsheets and see which one gives me that. Which table shows the relationship between the units? So they want this equation right here. Let me just come out here, listen spreadsheets, and start doing it. 257, 257. Oh, boy. Check. So looking at this one right here, we're going to look for the equation of y is equal to 5x minus 150. We're going to go with m to be 5 and b to be a negative 1.5. Okay? So on that one right there, we're again looking for the m to be 5 and the b to be 150. And somebody asked me, why in the world is it a 1.5 negative? Well, because that's a discount. It's taken off the price. Taken off price. So then the equations are, again, don't forget this, always in the form of y equals mx plus b. We always want them like that. We always want it where it's going to be y equals to mx plus b. We always want the m, when it stands for the m, going to be a slope each, every, per, daily, weekly, you know, all that stuff. And then the b will be that one-time thing here. Okay. Each month, 30. See it? Boom. 50 initial payment. That's how much initial beginning was this. Initially beginning, starting fee, all that stuff. There. And let's just go through like that. So saving $50. She earned range on the price. She earns $10 every week. 10 every. That's your M. So 10. Boom. That's a good giveaway, guys. Super easy stuff. Next one right here. So this one, again, is going to be, again, equations of y equals mx plus b. You always want the y equals mx plus b to be the format you always go back to, especially for listen spreadsheets. So y equals mx plus b. Looking at this stuff right here, what we have, we're going to have 2 points. You see that's a point right there, and that's a point right there. Mouse comes first, and then you pay. Money's always going to be second, guys. So this coordinate here would be 480 and 3162. This one would be 516 and 3185.40. Okay, so basically you want to have that stuff right there. This is spreadsheets, and then look for the coordinate here. So I'm going to go back to this spreadsheets. We should have them right there, 485. Let's start a whole new one. So then here I put the coordinates in there. Did this in spreadsheets, and we got y equals to mx plus b. But we're going to have 0.65x and 2850. 0.65x. I remember this part here. And there it is. Boom. But when you look at this, I don't think that's going to match up. 2850. This says 3. So I think it's going to be 0.65x plus 2850. And that's the real answer right here. Yeah. Contains that much right there. Is receding, means negative. That means negative, going down. 13 per week. So negative 13. There's my answer right there. Super easy. Okay, starts off at 3.9 and it's going down. So in here you got 3 and 6 times. So once I see this right here, I'm seeing 2 coordinates. I'm already seeing 2 coordinates right here. When I see these 2 coordinates, remember this is x, and then it becomes so I just type in the numbers over here. I should press enter, and there's this one right here. It's going to become the equation of y equals 50x, and then plus 5250. Put it 9250. There it is. Pretty easy. When it comes to the functions, this is probably the easiest one. Just make sure along the lines where, vertical line crosses at one function. This cannot have this part, throws it off. Okay? This word crosses twice, no. X is right here, repeat, no function. X repeat, no function. I guess they forgot to show you an XY table right here with the X's to repeat. 1, 2, 3, 9, 4, 5. Now you can put it 4 here, doesn't matter. We don't care about the Y side, we care about the X's. They don't repeat, it's a function. Okay, next question. Let's do this one. Again, vertical line test crosses it once. Function. Crosses it twice, not a function. Crosses it twice, not a function. Which graph, not a function. crossing it twice, out, out, not a bunch. Okay. Parallel lines transverse. Well, this is pretty easy. Remember, always there's only two angles here. There's only big angles and small angles. There's only angles that are bigger and obtuse, and smaller and acute. On the line, always at 180. So if I have 100 here, I have an 80 here. So now, from here on out, any big angle is 100. Any small angles are 80. Okay? If the angles are not equal to each other, then they add up to 180. If that makes sense. So this is 70, this one has to be 110. That one has to be 70 over here. It's a small one. This one has to be 110. This one right here next to it has to be 110. Two ways big enough. The big one or the line together. Remember I told you if they're not the same thing, then up to 180. This one right here, the 75 is a small angle. So this one also is a small angle. So this angle here is 75. Okay, next question. So this is pretty easy right here. Parallel line, yada, yada, yada. So this one right here, these are two small ones. That's a small one, that's a small one. That's 10, 10. If you're going to do extra work, you can also think about it here. That's a straight line right here. So this other side has to be 170. This has to be 170 here. This has to be 10. Now you got it. 50, 50. So this has to be 130. Why 130, sir? Because a straight line here makes it 180. 50 plus 130 would give me 180. Okay, these two right here, that's a 90. So this one has to be a 90 also. So they all are basically 90s. Looking at the straight line here, that's 140. This one has to be 40. And all the small angles would be 40, and all the big angles would be 140. Okay, based on the diagram, which is the value of x? Explain your reading. Explain your reading. Explain your reading for your answer. So x was over here, right? Okay, so these two are small, so that's why the x has to be 10. Or which it has to be. I don't know how we can do that. We can say it several ways. I'm just going to say because they're both small, I'm going to go with both being 10. That's it. Pretty easy. Mean absolute deviation. Don't forget the other come out here. There's this thing called MADSAT. Mean absolute deviation. Okay, you're gonna go and get the mean by adding, and you divide, then you go and subtract, and you add what you get again, and you divide again. I think it's pretty easy, not too bad. Always subtract the bigger one. Oh, sorry, let's get the bigger one and subtract the smaller one from the bigger one, and that's it. You always get a positive number, add these all up, and then you get a number, add them up, and then divide by how many numbers you added up, and there it is. Practice real quick. Mean absolute deviation from a 20, 40, 50, 20. So I guess we can do this. Let me get a calculator. Let me just get it set up here. So what I'm going to do here first is add all the numbers up. I'm going to go with 20 plus 40 plus 50 plus 20 plus 10 plus 70. Heads up, just because they're pretty big and spread out, they're going to be a bigger number, right? So I'm going to come out here now and I do that. I divide it by how many numbers are there? How many numbers are there? 1, 2, 3, 4, 5, 6. Divide by 6 and put a decimal. So give me a decimal already. 35. So what I'm going to do now is each one see how far they are from 35. So in my head I'm thinking about 35 and 20. How far apart are these two things? 35 and 20. What is it? 15. Okay. And then I guess I'll write it here. 15 plus, and then 30, 40 minus 35. 35, 50 minus 35, 15. 35, hey, forget about Robbie, don't get work. 15. 35 minus 10 will be 25. 70 minus 35 would be again 35. We'll wait for that. 25 here. And then 35. So I'm going to add all these numbers up. And since I kind of messed up. I could do it right. Do it again. So we're going to go with top R is 35, which is 15, plus 5, plus 15, plus 15, plus 25, plus 35, enter. And now let's divide that by 6 again. Numbers rounded up, 18.33. So that's 18.329. There's 10, my bad. So get rid of the 1. It's just 18.3. Okay, on this stuff here right now, this is pretty easy, guys. It looks like a slope, right? Basically, you apply it to a slope. Positive slope. Oh, sorry about that. Positive slope here. It's kind of weak. I would say kind of weak. Here's a negative slope. I would say kind of weak. This is like no association all over, just craziness. This is pretty strong. That's stronger than these, okay? That's my strong negative. And this is positive, right? Positive. This would be a negative. This one's kind of like weak positive. Outlier is the one that doesn't fit the area. This one's a non-linear. This one is parabolish. But in this situation right here, we're going to have it where it's a curve. It is a relationship, but non-linear, okay? Let's see what this other stuff is saying over here. Usually these guys draw a line through it. I'm going to give you one other number here. Find it. Where would it be? 260 here. Go to your line and go straight down to the other number, about 40. Oh, that's how it is. It's pretty easy. It's not too bad. Right here, it's got a pop right. What can you got? You know what? I would say no. No relationship. No pattern. No anything. Pretty soon, no? This is a positive one right here. Boom. Draw a line going through like this. Question's best. 18th month would be right here. Go to the line that you drew. Come across over here. Maybe about 45-ish. Oh, you know, I know. I would go about 42.5. Pretty good close to 42. Then you draw a line that goes through it. 9-year-old car. 9-year-old car. Go to 9 right here. Go right here. 135-ish. All right, not too bad. Not too bad. Okay, on this part right here, what you're going to come out here and do is make equations. This is from 7th grade, guys, when they told you how to come up with equations. And this is practicing just menu 3-1. And solve it. You all should know how to end solve it. Just write this equation right here, negative 3x, and then plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals to 5, all right, 5x minus 8. Comma x, and solve it, and it should give you this, okay? It's pretty easy. Remember, this is talking about the perimeter is 6. This is a reading question, guys. It's the same 6x is the perimeter, which is adding up all this stuff, and that has to be equal to all of these added up, which is x plus, I just can't see it there, plus x plus 3 plus 2x plus 5. See that? And then comma x and solve it, and it should give you, well, just clean it up basically. So 6x, clean this up, this, what is that right there? 2, 4, 5, right, 2, 4x. And then the numbers, you have a 3 here, and a 5 there, we get 8. So that's it. We have 5. Work is 8, yeah, perfect. That's where I'm at. Right here. So for these two right here, you do menu 3-1 just by the equation that's given to you. Boom. And you get the answer, right? This one over here, you'd have to write the equation out. Since they're positive, or they're like, I guess, no negatives on them, they're positive 3x. Plus 2 equals, this is 1x, and these are negatives, so it's a negative 6. Comma x, and so on and so on. This one here is a reading one, so just go through and read it, all right? Make sure you read it where it comes out with a 7x plus 1 are on the same side. And then the 10x is by itself on the other side over here. Take a few seconds to read it, and I'll show you which one it is. So on this last one here, basically look where these things go together. On these things going together, it's pretty easy in the sense that we're going to go with what? 7x, and 1. See that? 7x and 1. And then it's going to be the second day, the other one is 10, right there. Here you can see this is different right here. It's going to 7x right there, the per. And then it has the 10 per with the 1 together. No, wait, that doesn't go together. That one's out, definitely. 8 points, no, that doesn't make sense. This is out. 7 per and 1%, no, they want you to think of that, but no, 1% is way different, so that's out. Only possible answer, J.